Hi students, today we will discuss about the algebraic structure. The algebraic structure is very helpful in cryptography, communication systems, in all other fields. Especially groups concepts are very helpful in chemical graph theory and human genes calculation purpose. We are using that. Now we will see what is the algebraic structure. The algebraic structure is nothing but a non-empty set yes, together with the binary operation star, which satisfy the closure property. Now what is closure property? Let a comma b, for all a comma b belongs to yes, if a star b belongs to yes, then we can say that it is a closure property. Now we can say example n comma plus. We know that n is a set of all natural numbers. And plus is the binary operation we have. Now n contains the elements 0, 1, natural numbers 1, 2, 3, etc. The numbers. I choose two numbers. Say I can assign x and y be the two numbers. X is taken as 2 and y is taken as 5. Okay, the operation, binary operation is plus, so x plus 5, x plus y, which is equal to 2 plus 5, the number which is equal to 7, which belongs to n. So we can say that n comma plus is an algebraic system because it satisfies our condition, the closure property. Okay, now we can come to the n minus. So what about n comma minus? Here the set of all natural numbers with a minus is the operation. Okay, so here we choose x is equal to 2 and y equal to 5 plus 5. So what is x minus y? The binary operation is minus here. So what is the answer? 2 minus 5 equal to minus 3, which does not belongs to the natural number. So therefore we can understand that n comma minus is not an algebraic system. Okay. Next thing, based upon the algebraic properties, based upon the properties of algebraic system, we can define some other properties. One, associative property. Second one, identity property. Third one, inverse property. Already we defined already one closure property also. Now, I will explain about, already we explained about the closure property. Now we can come to the associative property. What is associative property? A star B star C is equal to A star B star C. For all A comma B belongs, A comma C belongs to the set either G, we can answer as G. What is identity property? A star E, the identity element, E star A is equal to A is called the identity element. Identity element is exists. The inverse, A star A inverse equal to A inverse star A equal to E. Then we can say that the inverse element present in the set. Based upon the closure, associative and identity property, we can define some concepts. One is semi-group. One is semi-group. What is semi-group? Semi-group is nothing but a non-empty set, yes, satisfies the closure and associative. Closure and associative. Okay. The second one is monoid. Monoid is nothing but a non-empty set satisfies the closure, associative and identity. Third one, group. Group. What is group? A set, non-empty set, satisfies closure, associative, identity and inverse. The last one is available. Fourth one is abelian group. Which is nothing but a group plus commutative property. Okay, now we will see the examples of the semi-group and monoid, next one group and abelian group. Okay, now we can come to the semi-group definition. So semi-group definition already we saw that. Now we will see the example of semi-group. So n comma plus, already we know that n comma plus is a semi-group because it satisfies the closure property as well as the associative property, but it doesn't satisfies the identity as well as inverse. Why means the identity element of plus is 0, but 0 doesn't available in n, therefore n comma plus only satisfies the closure and associative. Closure and associative satisfies. Okay. Monoid. What is monoid? Monoid is nothing but a non-empty set which satisfies the closure, associative and identity. Example for monoid is n comma dot. The multiplication, ordinary multiplication dot. See here n satisfies, the n comma dot satisfies the closure, associative property and the identity element is 1. So any number multiplied with 1 gives the same number. So here the identity element is 1. So therefore n comma dot is a monoid, but it is not a group, because if I choose the number 5 in n, I cannot find 1 by 5, which I cannot find 1 by 5 in n, because 5 into 1 by 5 is only gives the answer 1. 1 by 5 doesn't belongs to the n, therefore it is not an it does not contain the inverse element. So therefore n comma dot is an monoid. Next one is r comma plus. So r comma plus, you can see that clearly r comma plus satisfies what is that? Our group conditions. 1, closure is always true, associative is always true, 0 is the identity element of R, and inverse element is, suppose example, x is a number I choose in R, minus x is a number which is also available in R, therefore x minus x is equal to 0, the identity element of R which is available, therefore we can say R is a R comma plus is a group. Okay, what is an abelian group? Abelian group means it satisfies the commutative property. The commutative property is nothing but A star B equal to B star A. Now we will see some more explanation about group, some important properties and problems on the group. Okay, huh? Emmanuel sir, ஒரு 12:30 ஆனோன்னு சொல்லிடுங்க, நான் கிளம்பிடுறேன். 12:30 ஆனோன்னு சொல்லிடுங்க, கிளம்பிடுறேன். ஆனோன்னு சொல்லுங்க, கிளம்பிடுறேன். ஓகே சரி, ஓகே, தேங்க்யூ. Okay, now we will see the group definition. Already we discussed the group definition. So what is a group? A non-empty set S together with the binary operation satisfies the closure, associative, identity and inverse. Now already we see example R comma plus is a group example. Now some important properties which are available in the group. Let G is a G comma star be a group which holds cancellation laws. What is a cancellation law? Say example, A star B equal to A star C, which implies B equal to C. This is called left cancellation law. Similarly, A star B star A equal to C star A, which implies B equal to C, which is nothing but a right cancellation law. There are some important properties of group. First one is the identity element is unique. Identity element of a group is unique. Group G is unique. Second one, the inverse element of a group G is unique. Okay, now we will see. We can come to the first property. So let A be an element in G. We can assign, there are two identity elements. We can assign two identity elements E1 and E2 for G, for A. Already by the definition, since G is a group, since G is a group, what is the meaning? A star E1 is equal to E1 star A equal to A. This is by the definition of group. Okay. Similarly, A star E2 is equal to E2 star A, which is equal to A. This is also by the definition of group definition. Now I am comparing the values. A star E1 equal to A star E2. By cancellation law, what is the meaning? This E1 equal to E2. From that we can understand that the identity elements are unique. We can say if there are, we cannot find more than one identity element. That's the meaning of this. Okay. Similarly, we can come to the second property. What is the second property? The inverse element of G is unique. Let A be an element in G. We can find two inverse elements A dash and A double dash in G, for A in G. By the definition of inverse, what is the definition of inverse? A star A star is equal to A star A equal to E. Similarly, A star A double star, because A double star is an inverse element of A, so therefore by the definition this is also equal to E. Now comparing the values, A star A star equal to A star A double star, which implies A dash equal to A double dash. Therefore, inverse is unique. Okay, these are the standard properties or standard things, especially which are helpful for solving any problems in the group concepts. Now, we will see a problem in the group. Suppose I want to check G equal to 1 comma minus 1 comma I comma minus I is a group or not. Group or not. Also verify it's abelian or not. Also verify it is abelian or not. Okay. Now we can come to the G. So G is a element which contains with ordinary multiplication. With ordinary multiplication. So G is equal to 1 comma minus 1 comma I comma minus I with the operation star, with operation dot. Okay. For solving this type of problem, we want to use the Cayley's table. What is the Cayley's table? So first we fix that the number of elements 1 minus 1 I minus I, 1 minus 1 I minus I. So multiplication is dot. So I fit that data. So 1 into 1 1 minus 1 I minus I minus 1 plus 1 minus I plus I minus I squared. What is I squared value? Is minus 1, we know that. So minus I squared, the value is plus 1. Next one, minus I, minus of minus into I plus I, minus I squared, the value becomes 1. Here the value is minus 1. Now we can come to the closure. So for the closure, if you are choosing any element from the set G, the element, the multiplication gives the element which is also available in G. Say example, I choose 1 comma I element in G, I can easily found that 1 comma 1 dot I is equal to I, which is an element in G. So this is true for all elements. We can say that it is a closure property satisfied. Now we can come to the first category. Closure is over. Second one is associative. What is associative? A star B star C is equal to A star B star C. Okay. Suppose I choose the elements A equal to 1, B equal to minus 1, C is equal to I. So 1 star is a multiplication, 1 comma minus 1 multiplied with I. So what is the answer? 1 multiplied with minus I, the answer is minus I. Okay. Similarly, which is nothing but A dot B dot C. Now we can come to the A dot B dot C. See then 1 multiply with a minus 1 multiply with plus I. So what is that? Minus 1 dot I is equal to minus I. From that we can understand that A dot B dot C is equal to A dot B dot C. So therefore the closure property satisfied. Next we go for the identity property. What is the identity element? Any number we choose which is multiplied with 1, which gives the same number. So here I is the 1 is the identity element in G. Now come to the inverse element. What is the inverse element? So here the inverse element of 1 is 1, inverse element of -1 is -1, inverse element of I is -I, minus I is plus I. Therefore, it becomes a group because it satisfies the closure, associative, identity and inverse. Therefore, it becomes a group. Now we want to check it is an abelian group or not. So for abelian group, it must satisfy the commutative property. So we choose two numbers, a equal to 1 and b equal to -I. So what is a dot b? That is 1 dot minus I, which is equal to -I. Similarly, b dot a is equal to -I dot 1, which is equal to -I. From that we can understand a dot b equal to b dot a, therefore it is commutative. Therefore, G comma dot is an abelian group. This is one example for the group conditions. Now we will see another one example in the group session. Okay. Problem 2. Let q comma plus star be a set defined by a star b equal to ab by 2. Prove that q comma star is an abelian group. Okay. Now we can come to the definition. So here it's not a normal multiplication, it's a different multiplication which is defined by a star b equal to ab by 2 for all a comma b belongs to q. Now we can define that set. So for all a comma b belongs to q, a star b equal to ab by 2. This is the definition. Now we want to come to the closure for the problem. Let a comma b belongs to q. By the definition, a star b equal to ab by 2, which is also belongs to q. Because if I choose a equal to 5 and b equal to 3, the number 15 by 2, which is also belongs to the q. So clearly it is a closure. Next one, we can come to the associative property. Let a comma b belongs to q, a comma b comma c belongs to q. Now a star b star c, the answer is a star bc by 2, which is nothing but it comes under a star b model. So it's nothing but a times of bc by 2 divided by 2, which is equal to abc by 4. Similarly, a star b star c, that is a star b is nothing but ab by 2, star c is nothing but ab by 2 into c divided by 2. Therefore, abc by 4. Therefore, it satisfies associative property. Okay. The third one, the identity element. Now, we can assign E be E is the identity element. Okay. Now what is the definition? A star E equal to E star A equal to A. This is the definition of the identity element. So what is it? A star E? A star E is equal to, by the definition it becomes AE by 2, which is equal to always E. By cancellation law, what is the E value? E value is 2. Therefore, E equal to 2 is a identity element in Q. Close பண்ணுமா? இல்லை நான் முடிச்சிடறேன், இதோட முடிச்சிடறேன், ஒரே நிமிஷம். U equal to 2 is a Q plus, which is an identity element. Now we can come to the inverse element. What is the inverse element? Let A inverse be the inverse element of Q. So A star A inverse is equal to E. The E is the identity element is 2. So therefore A star A inverse is equal to 2. Therefore A inverse by 2 equal to 2. We want to find the A inverse. So A inverse is 4 by A, which is also belongs to Q. So therefore it contains the identity element. From that we can understand that Q comma star is a group. Now we want to prove another one thing, that is called abelian group. What is abelian group? We want to prove it is a commutative property. Okay, now commutative property, the fifth one, commutative. A star B equal to AB by 2. We can written this as BA by 2, which is nothing but the definition B star A. Therefore G Q comma star is an abelian group because it satisfies the all properties: closure, associative, identity, and inverse, and as well as the commutative. Thank you.